And we're up here mainly to assess the traction control, stability control and the ABS calibrations in the vehicle. And one of the other tasks that I'm doing is to assess the off-road capability of the vehicle, so driving through deep snow and up steep grades. And we also have a number of handling tracks, 4 in total, which the handling tracks are good because they're much narrower. It gives the driver an opportunity to see how well-rounded the vehicle is in terms of stability and its overall handling.
If the vehicle's understeering, it'll apply one of the rear brakes and set up a torque moment. And it also, in this case, I've got my foot wide open on the throttle, and it will reduce engine torque. And the combination of the two provides it with some stability, and nothing's happening. It's not sliding at all.
There are 2 gradients. One's a 17% grade, the other one is a 28% grade. Now the idea is that you attempt to drive the vehicle up those gradients. Now because it's a split mu or a split friction surface, that's quite challenging for the traction control system to manage. So it's a test that's used to determine how well the traction control system functions in the vehicle.
Degrees outside, and so this ice will actually be fairly sticky, and we have to actually polish it by constantly doing, we'll turn the ABS off and we just basically slide along there. We have to polish it about 10 times before we can do consistent measurements. When you're here later in the winter season, the days warm up a bit more, and as it gets around about 0 degrees, it becomes very, very slick. And so you can actually get this very large difference between the ice itself, and depending on the temperature.
There's a dynamics area which allows pretty much free-form testing. We often do slaloms or lane changes there. But generally it's a wide open space that allows the test engineer to test the dynamic stability of the vehicle.